Okay. And let me give you a moment to copy this example down. Okay, so here we're being told that we have two solutions to this homogeneous differential equation. Why is this a homogeneous differential equation? What makes y double prime minus 7y prime plus 10y equals 0 a homogeneous differential equation? Good, Andre. You have a 0 on the right-hand side. Okay. Now, if this is the case that we have two solutions to this homogeneous differential equation, what we want to do is find a general solution to the non-homogeneous differential equation. And it's non-homogeneous because on the right side of the equal sign, we have a non-zero function, 24 times e to the x power. Okay. So on that note then, we have to figure out a way to solve this little non-homogeneous differential equation. Okay, so let me outline how we're going to get there. I'll go to the next page if that's all right. Okay, thank you everybody, thank you. So just a little reinforcement here of things we've talked about in section 4.1. The two solutions that are given to you, and you're going to learn a little later here how to get those solutions, but the two solutions that are given to you are linearly independent. Okay, they are linearly independent. One of those functions is not a multiple of the other function. In this case, with just two functions, it's easy to see. And so the two solutions form what's called a fundamental set of solutions to the homogeneous differential equation. Now I'm going to give you a chance to catch up here, but this means then, by what's called the superposition principle, that the solution C1 times e to the 2x power plus C2 times e to the 5x power, that's also then a solution to the differential equation. And it's a general solution to the, and I should say it's a solution to the homogeneous differential equation. I should add in here, insert homogeneous. Homogeneous. One moment here, let me just fill that out.
Wait, you said we're going to go over the superposition principle later, right?
Well, the superposition principle just says that if you have two linearly, like if you have we have a second order differential equation, and we have two linearly independent solutions to that differential equation. I mean, so check it out. You can substitute them in. You'll see that they are solutions to that homogeneous differential equation. Well, being that's the case, then, if we wanted a general solution to the homogeneous differential equation, all we need to do is take a linear combination of y1 and y2. Just take a linear combination of your two solutions, and you will then get a solution to the differential equation. What we have here is C1 times Y1. Hold on, let me make that a little nicer. What we have here for this general solution is we have C1 times Y1 plus C2 times Y2. That's the superposition principle. If you've identified solutions to the homogeneous differential equation, then a linear combination of those solutions is also itself a solution to the homogeneous differential equation. And we actually call this linear combination here a complementary function. That's why I have y sub c here. Now, I don't have to put the little c there, but you're going to see why I put it there. But we call that a complementary function. So, for instance, if you had a third order differential equation, homogeneous differential equation, and you found three solutions to that homogeneous differential equation, then the linear combination of those solutions would be your general solution to the homogeneous differential equation. You see, we're always interested in the general solution because we want to make sure, are there any other solutions out there? Well, the answer is no. This is the general solution to that homogeneous differential equation. And obviously C1 and C2 can vary depending on what your initial conditions are. But we're not worried about solving it. And you know how to solve initial value problems. But we're not worried about that here. But now what we want to do is we want to go after the solution for the non-homogeneous differential equation. Okay. Non-homogeneous because we have 24e to the x power on the right-hand side. And what we need to do in order to go after the solution for this non-homogeneous differential equation is we need to make an educated guess as to a particular solution to the non-homogeneous differential equation. So the question is, what would a good guess be? What would a good guess be if we had to make a guess?
Professor?
Yeah, Mark. Yep.
Like if you said 24e to the x, wouldn't that then have the 0 on the right side, so it would be homogeneous?
Well, no, 24e to the x is on the right side. We're not going to subtract that over to the left side. We're going to, that's on the right side. And we're going to, we're just going to leave it there. And I mean, if you notice, Mark, like the first differential equation was y double prime minus 7y prime, sorry, y double prime minus 7y prime plus 10y equals 0. Okay, let me go back to the original thing here. What's the only difference between the homogeneous differential equation and the non-homogeneous differential equation? They're almost the same differential equation, except the right-hand side differs. You see? And so that's why, because we have a non-zero function on the right-hand side here, that's why that's called a non-homogeneous differential equation. So we're not going to move it or anything. We're going to leave it right there. Does that make sense, Mark? Does that? All right, excellent, excellent. So now we have to solve this non-homogeneous differential equation, and we're making an educated guess. And Michael suggested that for a particular solution, we could guess some constant times e to the x, and that's correct. That would be a good guess. That would be an educated guess, because we know if we know that when we substitute that whatever solution we're going to substitute in on the left-hand side of the differential equation, we're going to have to take first and second derivatives. But in the end, the left-hand side has to equal 24e to the x. So the derivative of e to the x is e to the x. So this is a very good educated guess. And we're gonna run with that on the next page. But let me just see here. There was Michael says, right, the right-hand side has terms in y and its derivatives. Okay, all right. So Michael has the right idea. So let me show you how this works. But may I go to the next page? Is everybody comfortable so far? All right. Well, of course, if this y sub p, this particular solution, is a solution to the non-homogeneous differential equation, it would only be a solution if we can figure out what that value of c is, what that coefficient is. So what we're doing, Matthew, is we're trying to make a good educated guess here. And I know what you're thinking. Like, gee, this isn't like like when we solve a differential equation by separating the variables. We go through a routine. We separate the variables and do integration. And here we are just making guesses, right? How does that really math like? Well, you're going to see. For now, it's okay, because think of it like this. Let's say you had something like 2 plus x equals 5. 2 plus x equals 5. And let's say you didn't know any algebra, but you made a guess that x equals 3. Okay, let's just say you guessed x equals 3. Hey, that's a good guess. 2 plus 3 does equal 5. So even though here
You can just plug it into check. Yeah.
Yeah, and even though you made a guess, the guess was a right guess. Now, of course, for we want to, of course, get down to the theory why it's true. But right now we're just making that guess. So we're going to make the particular solution equals a constant times e to the x. Let's check it out. So if that is our guess, then here's the first derivative of the particular solution. That equals c times e to the x. And here's the second derivative of the particular solution. That also equals c times e to the x. We're going to substitute in the particular solution and the two derivatives into the differential equation to try to solve for C. Okay. And that's outlined here. Let me give you a moment to catch up here. Let me know if you have any questions.
Quick question. Shouldn't we have a different, like, constant for each of these two differential equations? I don't know.
Well, the thing is, our guess is simply C times e to the x. And when we substitute the guess and its derivatives in, we end up then with C. We end up with, we combine the terms here and on the left and get 4 times C times e to the x. That equals 24 e to the x. So that means C has to equal 6. And so that's going to be our particular solution. And then there's another superposition principle then that says that for this non-homogeneous differential equation, the general solution is just going to be the complementary function y sub c of x plus the particular solution. That's this superposition principle. And you could verify, you could show that this entire solution, it's a general solution to the non-homogeneous differential equation. You could check it out and see that it satisfies the differential equation. And there are, I mean, this can be proven, but when you do enough practice problems, you're going to intuitively feel comfortable with this. You will. So Matthew, this solution here is just to the non-homogeneous differential equation. This solution is not a solution to the homogeneous differential equation. It's a general solution to the non-homogeneous differential equation. Are you comfortable with that?
Yeah.
Okay. So you're sort of taking this on a little bit of faith now, but once you get enough practice, it's intuitively going to make sense. It's kind of like, how many have seen? Well, you've all seen Star Wars. How many like Star Wars? With I love analogies. Okay, David likes it. All right, David. Who's the like the hero now? Is it, what's her name? Jay? I'm trying to recall her name. The like in the modern ones, the hero, Ray. That's it. Well, and then that's like you all. You're learning the differential equation force. Okay, and all right. Oh, okay, all right. I assume Matthew's joking there. All right. Are there any questions on that?
I have a question, Professor. Why is
Yes,
it the
Antonio.
whole thing instead of just 6e to the x? Where do those?
I'm
Why do
sorry?
those c come back in?
I'm sorry. All right, hold on. So are you comfortable that C equals 6, Antonio? You're okay there?
Yeah.
So it turns out by the superposition principle that all you need to do to get the general solution to the non-homogeneous differential equation, all you need to do is identify the complementary function and the specific particular solution. It's particular because there's no constant there, unknown constant in that particular solution. And just add them together, and that assures you have a general solution.
So why do we need the complementary function?
It just turned, well, you're getting a general solution. So a general solution has to allow for variability, because you have a differential equation, but you haven't been specified any initial values. You don't know what y of 0 equals. You don't know what y prime of 0 equals. But if you are given those initial conditions, then you can solve for these constants. And so we look for the general solution, a differential equation without initial values. If you recall, a differential equation without any initial values, the solution is a general solution.
Right. So the complementary function, since that's a general solution for the homogeneous differential equation, is it because that was the same as the non-homogeneous other than the right side that we put that in there?
That's right. That's exactly right.
And then yp just accounts for that term on the right side?
That 24e to the x. Yes.
Okay.
Yes, that's right.
Okay, I'm with you now.
All right. Very good. Very good. All right. And Matthew likes the first 3 Star Wars movies, by the way. Good question, Antonio. They're very good, the first 3. All right. That's basically section 4.1. If there are no other questions, I'll stop the recording.